Hello world, welcome to Coding a Roguelike in C. I'm Petey, welcome back. This is day 49, I believe, of our little adventure here, and things are going along well. We are really kind of winding things down, wrapping up scope, the predefined scope for this little game, and I'm quite pleased with the way things have come out so far. So today we're just going to do a little bit of fun, a little bit of cleanup, and then a little bit of fun. So last stream, if you remember, we someone from chat found a little memory bug due to the fact that we were using malloc instead of calloc, and so I think it would be wise at this point to kind of look through the code base and make sure that we're initializing our memory properly and kind of cleaning things up, or starting things with a clean slate using calloc instead of malloc, because malloc just kind of allocates a chunk of memory of a given size, whereas calloc will not only allocate that chunk of memory, but it will zero it out. So there won't be any leftover junk from other applications or other uses within our own application of that memory. So you'll also remember last time we built our windscreen. So maybe we'll just jump right in, and let me comment this, uncomment that, and just kind of show people that might have missed it the windscreen that we built. Let's launch things up. I haven't built recently, so hopefully everything's still working. Looks like it is. So this is our launch screen. Chain Revenge, thanks for the follow. I appreciate it. Welcome to the stream. Okay, so here's our kind of our launch screen, and then got our new game. Oh, there's a gem right here. We should go grab that. And then we can trigger the win condition by hitting W. And then you can see this is our win screen. Hero's teleported back to the surface. Hooray! He's achieved level 20, and he's picked up 1 gem. I don't know that that's enough to make the Hall of Fame. We did reset the Hall of Fame. And so that is our win screen. So let's go through and kind of do a quick look for malloc. And replace those calls with calls to calloc, because I was seeing some problems as we were descending through the dungeon levels. It seemed like there were these phantom objects that that were in the map or at a location in the map, and as we crossed over them with our character, it would log something like, hey, there's a sword here, but there wasn't a sword appearing on the screen. So I think that is due to not completely cleaning up our memory when we move from one level to the next, or else we are cleaning it up, but then we're using malloc to reallocate, and for some reason it's still, it's got a sword from a previous level in a location, and it's not. It thinks that it's in that location on the new level. So let's just do a quick pass and change our mallocs to calloc and see what that does for us. I think it will help. At least it will let us, if we're still seeing problems, eliminate one cause of those problems, one potential cause. So let's just jump up to the top, start from the top, work our way down. This is right in our world state management. We get our appearance probability. Again, I don't know that this is gonna do anything. So the call signature is a little bit different. Where malloc, we just hand it one parameter where it's the size of the memory we want to allocate. For calloc, we need to give two parameters. And the first is the count of the things we want to allocate. And then the second is the size of each one of those things. So string length, appearance prob, that's going to be our count, and then we'll do size of, we're going to be allocating characters here. And we're using version control, so if this turns out to be and have awful consequences, we can always roll back. Always use version control to save yourself from yourself. And so guess max counts, string length. This is going to be a similar call. So in this instance where we are allocating a new struct, I have to look it up. I think that modern C will automatically initialize a struct's memory to 0, but we'll do it here just to be safe. Those. See another one. So this is going to be our size. Oh, it would help if I actually changed those to calloc calls. Whoops. Genius. Yes. Step 1, change the name of the function. Step 2, actually change the signature. Okay, so this is the one that I think might be a likely culprit for our issue, where we're allocating the map with a memory for the map of the level. We're not zeroing it out, so I think this might help quite a bit. How's everyone doing this morning? Hope all is well. A little bit of Sunday coding. So this is a bunch of bools, I guess. So we'll do almost done. Size of message. Okay, and then got our string. All right, let's just look. So that's our game file, which is our primary. That's where the the biggest chunk of our code is, but let's just do, let's check through all our stuff. Got some in config too. That might be a good place to do some replacements. With the strings, I'm less concerned. I don't know that those are truly necessary, but for the sake of completeness. You're doing tedious stuff like that, it really helps to have good music, which is nice. Takes a little bit of the tedium out. Oh my goodness. This is not my usual keyboard, so I'm gonna get all sorts of. As a pointer at the function, send a pointer free. Yeah, do that. Okay, now here's some of our map stuff, so this might be helpful as well. Just make sure everything's in a known state before we... Is it? Segment. This is where we're building out our hallways. Building some hallway segments. Already been there. I'm going to ignore that one. It's in the comments. It used to be that people would say that C-alloc was unnecessary and it would be a performance hit, and if you're truly looking for every single clock cycle, then it is slightly slower, but for all practical purposes, it's worth the very, very minimal trade-off in performance for the kind of the known state of memory that it gives you. Really, there's not really any performance hit to speak of. All right, I think this is the last one. Oh, there's a couple hiding behind that drop down. Nice. This is all. Yeah, this one's going to be good to do because this is our UI. So this may be part of the issue that we're seeing. Size of key. This just gets a comma. Let's see. Width, height, size of. Interested to see what, if any, effect this will have. See that? Just a sec now. Alright, so we've swapped out all of our mallocs for Seog. Let's do a build and see what we can. Some of these guys out first. Okay. F5, let's see if everything builds. Does two. UI 650 for 6. Uh, 650. So we've got 2, 3, 4, 5, 6. The first char. First character font file. 2, 3. Wait a minute. Normal parameter 6. 6 the background color. I feel like that's let's go into game 551. Ah, we missed one. Still doesn't like it. Equipment. Oh, I totally missed that. Okay. Seems like we built. Everything seems to be running. Let's see if we can descend a staircase if we find one. Let's just run until we... Oh, corner. Hey. Oh, we're died of this bat. And we're dead. Okay. Let's try this again. Just to check descending a staircase. You can never find stairs when you Okay. Third time's a charm, right? Hey, user man. How's it going? Thank you. There's our stairs. Okay, let's descend. Okay, so it seems like nothing is obviously wrong. Let's equip this. Start killing and see if we can uncover things that might be a problem. Looks good so far. So we're looking for things that might be like phantom objects from previous. Oh, look, like right here. Saw it right there. Thinks there's a shield there for some reason, but it's not visible. Tried to make things like this, but never really got that far. Yeah, I think one thing that helps is to define a scope of work that's somewhat limited. Like don't swing for the fences right away. Complete smaller projects first, and then build on those successes. We have purposely limited the scope of this project. And now it's nearing completion, so we can finish this off and move on to the next bigger and better thing. So we're still seeing those phantom objects. That might be. Alright, let's just, do I still have my kill screen in? No, I don't. I commented that. Let's just go for wind. Ooh, wind. Alright. So we did clean up our memory. Didn't seem to help with one thing. Am I using libraries? No. The only library that I'm using is for the underlying access to the graphics. I'm using SDL, and that lets me, it kind of hands me a set of memory that represents the screen, and then I can write my pixels right to the screen. I am not using any sort of game engine libraries. I've built that all. Go look at this level code. Level init. Clear the previous level from world state. So I want to make sure that this is actually working. For the game objects, we are it's not the player, it's not unused. Then we'll search the oh, and it's not in our list of carried items. Then we destroy it. Still carried items, let's see. You do C# Python? Yeah, yeah, sometimes the linking stuff takes a while to get right, getting the libraries in the right place, and sometimes it's a bit finicky. if you do Python though, like there should be Python bindings for SDL, or like through Pygame or something. I think Pygame is built on SDL, if I'm not mistaken. Generate level map into the world state. So I generate new map cells. Ever clean up the old ones? C++ because of performance, trying to make a simulator. Well, and again, this is if you're using it to learn, you know, as an exercise to learn C++, I say go for it. If you're looking to kind of test out an idea or you know, like a prototype of your game, like I would just stick with what you're comfortable with and build it, and then measure your performance and decide if it's something that you need to optimize or if it's good enough. It's good enough, great. You're done. And then if there are pieces that you'd like to optimize, then look at kind of rewriting those components in C++ or C or something like that. Sprinkle some items through. See if if somehow we're generating an item where we're not doing the visual. Yeah, I mean, I'd say try out your idea in Python and just get the algorithms or the simulation dialed in, and then if you need to, you know, rewrite it for ultimate performance, then do it. But at least you'll have built at least one iteration of it, so you'll be more familiar with the problem you're trying to solve, and you'll, you know, you may find things that you could do better, that you kind of wouldn't have found unless you actually build it. Okay, visibility. Putting these items. It's misleading. And the level cleanup function. Sentinel, thanks for the follow. I appreciate it. Welcome to the stream. How's it going today? What else did I want to do? Oh, the new game. That's another thing we found last week. When you start a new game, the gem counter is, we don't reset those. So let's do that. Gems found this level and the gems found total. Don't think we ever reset this. Which is a problem. So let's do... I think we are clearing gems found this level though. Yep, right. Okay, so let's look at game. What? Game. It's not gaming it, huh? Alright, let's find it. Game new. Okay, so world state init, this would be a good place to put it. It's an easy fix. Actually done it in Python. Found more advanced on the screen. It slowed down a lot. Changed all our mix.
Tuning out of starlight, the innocent lifetime flickers and flashes.
See if we can find a gem.
No, nobody seems
Die.
worth it, while the feeling's sophisticated. The view is so restrained. The past is nearing closer and closer. I fear.
Let's see.
Cut the bullshit and tell me who's independent. Thumbs twiddling and your life's escaping.
So we can see down here what our stats. Gem.
Well, yeah, ain't as free as it used to be, but that's quite alright when you're still 18, it seems.
Yeah, we can kind of. So let's unequip that.
What's a beautiful person with some hideous dreams?
2 gems start a new game, and gems are 0 now. So
The
yeah,
lining isn't silver.
if we die, we've got 0 gems. Good.
That'll take us home. The edge of us is getting weighed. Read about your life in your local papers.
Yeah, I mean, like I said, if you're interested in using, in learning C++, then yeah, I say go for it. It's a great way to learn is by actually just building something. How do I do the vision detection for what blocks are directly in your so there's where did I put that? That's been a while, so let me refresh my memory. I think I'm basically generating a vision map. So if we go into our game loop, it's probably game update. Just in the environment. Left arrow, I always miss that. Maybe it's the target map. I actually remember where I put that. It's for updating the target. So for movement and monster movement, we do a Dijkstra map. But for the roughly speaking, for the vision and the fog field of vision stuff, we're essentially like casting out rays in different directions and seeing when we hit a cell that is not visible. And once we hit a cell that's not visible, that ray stops. But if you'll look let's do this. Yes, I hit too early. Okay. So, as part of the vision, each cell has some properties, and one is, can you see through it? So floors, you can obviously see over the floors, but you cannot see through walls, which is why some of this stuff's blocked off. So we're throwing, I forget how far we go. Looks like it's maybe 2, 6, 7, 8, 9, maybe 9 or 10 out. And so we're basically just starting with the player. We're kind of looking out, and we go until we find a block that the user can't see past, that doesn't allow visibility past. So like once we hit over here, we don't check any of the rest of these because we know that they're all hidden once we've hit these blocks. If you want to really look at the algorithm, the source code is above in the repo that's listed above my head. So feel free to download it, check it out, modify it, see what changes can be made, tweaks. Yeah, and it's vanilla C, which will work. Also, it'll port pretty cleanly to C++. If you want to borrow, use it, build on it. All right. The one, so we did a bit of cleanup. Now I thought we'd start on something a little bit more fun, which is building a kind of lightweight animation system in, and yeah, it's a turn-based game, so the animation is it's just there for visual appeal, and we're certainly not going to go crazy with it, but I think it's an interesting problem. How do you animate something in a turn-based game, and how do you distinguish between kind of advancing the state of the world, which only happens when the player moves, versus animation timing? So I think we'll build out a simple animation system, and maybe we'll start with something simple like making our gems in our dungeon kind of sparkle every so often. And if we build that kind of, if we implement that, we should be able to extend that animation system to do whatever we want. So I wrote up a couple notes. The basic plan is to have an animation system that runs every single frame. So every time through our game loop, we're going to check the animation system. There'll be a queue, and we'll look at the animation queue and see if there's any work to do. And if there's no work to do, fine, we just continue on with our frame. If there is work in the queue, we'll pop something off the queue, run the animation, perhaps put it back on the queue depending on the animation itself, and then continue with the rest of the frame. So we're going to need we're going to need to define some data structures to support the animation. And I'm thinking, is this something that we want to make a component of our entity component system? Do we want like an animated? Guess we do. Can make it a game object. So we'll create a new structure, and we'll call this one animation. And so the types of information that we're going to need to store, I think, we'll need some kind of countdown. So we'll want to know, animations have these keyframes, which is when something actually happens to change the visuals. So we'll have something that is a kind of frames. Keyframe. Interval, maybe? Which is the number of frames in between keyframes. And then we'll have the keyframe countdown. I think we do ticks until keyframe. That seems kind of remain consistent with our keyframe. And then so we have the interval between keyframes. We're going to have a countdown, a tick counter that we're going to decrement through every time we hit a new turn through the loop. Can C++ structs have methods? No, structs cannot have methods. In C++, you can have a class that is in some ways similar to a struct and in some ways different. But in C++, you can instantiate a class, and that'll hold your data, and it can also have your methods that operate on that data. So we've got the keyframe interval, we've got ticks until keyframe, and then we need a way to describe what changes happen during a keyframe update. So I think what we're going to want to do there is just have like a pointer to a function that can be called to actually perform the animation, because we want this structure to be able to support kind of any type of animation that we may want to build. So by defining it as a function pointer, building this animation, we can assign it any kind of work that we want. I'm trying to see if we have any other. I don't believe we have any other functions in our entities. Or sorry, in our components. This is our main game loop. This is where we'll probably in our game update we'll add a call to the animation system. They're not being questions are never annoying. We're all here to learn, so don't worry about that. To set values in a struct instance, do you have to create an instance of one, then set its values? Yes. So in C, you need to allocate a struct either dynamically using malloc, or you can build it on. You can do it on the stack. But you have to have allocated the memory before you start setting its values. And then in C++, if you're working with a class, yes, again, you need to instantiate a new class. And I believe in C++, it's been a long time since I did C++. I think you use the new keyword to allocate the memory for that and kind of call its constructor. But yes, if you do not allocate memory, if you have like a pointer to a structure and you don't allocate the memory and kind of clean that out before you start using the structure, it could lead to bad things. Alright, where am I? Here, you make it active screen. It's been a while since I looked at this stuff, so I'm just refreshing my. Just want to look and see. Oops. So the language where you just define constructors? Yeah. Well, then you'll I mean, C++ is one of those languages, so that should be familiar to you. Alright, so it's interesting. What is an underscore block? It says it's an Objective C. Just want to do a straight up function pointer. So thanks, Firefox. Refresh my memory. So this is our declaration where it's just a pointer to takes an int. because the syntax is a little bit wonky, so int. You just have to have the parentheses around the variable name, which is kind of the oddness. Alright, so if we do let's just burn this. We'll call this keyframe and it's not going to take anything. It's just going to take void. So it's a pointer to a function that we're going to call keyframe animation, and that function takes no parameters. Do I have a working demo? Yeah, I've got. Show you real quick. It's more than a demo. So here's our starting screen to our Hall of Fame. Exciting. And then explore the dungeon to find all the gems. There's 5 gems on every level, so you can try and discover them. We got lucky this time because there's a bunch of them right here, but we have no weapon and there's monsters coming at us, so let's try it. This one. Is there a version of toString for structs? Or would you have to make a function for this? In C, you would need to make a function. For structs, there's no toString. So you'd probably have define a function. You could call it like toString, and then you'd pass structure to your function. And then the function would handle putting stuff on the screen, or turning it into a string. Let's get the helmet. Now we're fully kitted out. Yeah, so this is kind of what the game looks like, and equipment degrades over time, so maybe we'll just grab this sword so that if our battle axe falls apart, we still have a weapon that we can equip. So, looking for the stairs. We found all the gems for this level. Let's see. Just haven't found the stairs. Where are those things? There they are. So the field of view, you can see. This is the field of view. It's the light cast by our torch, if you will. However, places you've already been, you've kind of mapped those out, so they'll still appear, but they'll be dimmed out. And monsters will not appear because we want to have that mystery. Where are they lurking? However, the stairs will continue to show up once you've found them. And once you descend, we generate a new random map, and you're off adventuring again. And as you descend further into the depths, the creatures that you will encounter are nastier. But also, as you progress, your own skills kind of scale as well to make it somewhat fair. So you see we made the leaderboard here, we're number 2, we got to level 3, and we found 6 gems. So the number that comes as a result of print a pointer to the memory address. I'm not 100% sure what is returned from print. Look it up real quick. See. The total number of characters written is returned, so yeah. It's not the memory address, it's the number of characters that were printed. Because printf, you can do formatting, so the format string that you specify may be different than the string length that comes out. Alright, so we've got our animation component. We may, I imagine we'll want to add more properties to this, but this should work for the moment. Just consult my notes. So yeah, each... Oh, I have a note here that we can do timing. We may want to do timing based per frame or per move. Let's leave that until later. That can be an expansion. For now, we'll just do timing per frame. So timing will be measured in loops through the game loop. So we've got our structure here. Let's see where we got our main game loop. Do a game update here. This is called every single tick. And then, so if a player took turns, this would be the stuff that happens every. And we then recalculate the field of view. So, Userman, you were asking about field of view earlier. If you grab the source code, this FOV_calculate method is where you'd want to check it out. It basically generates a field of view map that we then factor into our rendering algorithm when we're rendering the map view. We check the field of view map to see if something's visible or not. So we'll recalculate the field of view and then check for animation updates, maybe. So we're gonna need a structure to hold our animation queue. I think we'll just use a list for that. So we'll come back to this. Jump back up to the top here for a second. We have our animation structure. Let's do this to hold it. Give me 1 sec. I need to take a quick break. I will be right back. Okay, I apologize, you know. I'm back. Alright, let's do this. So, I think it'd be best to store our animation queue. I'm calling it a queue. I don't think it's actually going to be a queue because every time through the loop, we're going to look at everything. Everything in the collection, or all of the items in the. We'll just call it a list because that's what it is. You know, when we create an animation, we're going to put this data structure on our list. Every time the game loops, we're going to loop through all of the animation items in our list and check them to see if we need to do any animation work for that particular animation this frame. If it turns out that we do need to do animation, then we're going to call the function that is associated with that structure. If we don't have to do any work, we'll just decrement our counters and put it, leave it on the list. Also, that reminds me, we're going to need some way to determine when to take an animation off the list. So, yes. All right. We'll do that in 1 second, though. Let's just allocate our... It'll be a list, and it'll be... we'll call it animation. Animation list. Seems pretty reasonable. Define it, set it to null initially. And then in our game, what did we call it? Game new? Game new. We do our world state init. Do we want to do it in world state init? I guess we... I don't know that we want to do it in the world state init. I think we just want to do it kind of out here, generate target map. We'll do animation list equals CL. List. Oh, gosh, it's been so long. Let's just look at our list function. Should be a list new. Turns our list pointer. So we're just going to do list new. Yep, so this will allocate our list. It creates an empty list of size 0 and just kind of initializes all the data structures that we need to hold the metadata about our list. What is it all? So we did our animation list is list new. That's good. That's all we need to do right now. Let's jump back to our animation structure because there's a couple things I realize we need to add. We need a Boolean that says maybe loops. Do we want to do loops forever? I think maybe we just want a finished. See your question. Is there a diff between type def struct foo versus type def struct foo? So, alright, so this is like a shorthand in that it will define the structure and then it also names it. You could also do it you could also do type def struct dungeon level, for example, here, or type def struct animation, and then have your semicolon here, and then do type, or I'm sorry, but have your struct animation and kind of define that, and then do type def struct animation. This is just kind of a in either C99 or C11, they added this shorthand where you can define the structure and also name it, which just makes it easier. So we're going to add this bool finished, because for some of our animations we're going to want them to run once and then be done. But for others, like for the one that we're building with the gem kind of sparkling, we are going to want to just run those forever, continuously. So we'll have this finished bool that once the keyframe animation function runs, it will probably set this value, and then each game loop we're going to need to, when we're going through the animation list, we're going to need to not only check to see if there's keyframe work that needs to be done, but we're going to need to check to see if an animation needs to be cleaned up. So if an animation is finished, we're going to remove it from the list so that it's done. So we've got finished for that. So let's go to our game update. We'll do let's just do it animation update, because we've got environment update, we've got health removal update, all these different update functions. We'll do health, we'll do animation update. And do that. Game routines, maybe we'll just do just add something right here. This won't take any parameters because we're going to be using our global animation list. And so what we want to do is look at all animations in the list. And do any necessary keyframe work. Let's say cleanup or keyframe work. This music is a little bit too robotic for me. Let's put along, people. Borrow my list looping code here, and we'll adapt it for this situation. This loops through all the items in our list, and instead of looking at game objects, we're going to be looking at animation. Animations. Oops. Game object animation act. It's not really what we're looking for. So we'll loop through our animation list, and then we'll grab each item out of the list and figure out what we need to do. So the first thing we want to do is we want to see if the animation is finished, we want to clean it up and get rid of it. So we'll check if anim finished. Move. So animation is done. Clean it up. So we'll do list. Is it list from move? No, list from move. Zeitcatcher, thank you for the follow. I appreciate it. How's it going today? Do list remove to get this stuff. To refresh my memory as to which function I'm actually going to want to do. Let's look at this guy. Problem with coding, working on a code base once every week or two is that. Oh, thanks. I appreciate it, Zeitcatcher. Insta follow, yes. Are you a fan of C or roguelikes or both? SKC, thanks for the follow. I appreciate it. Welcome to the stream. All right, so list remove. It removes the given element. Okay, so that's what we want because we actually have the element. If we remove the element, I think that might kill our C then roguelike shaman. Okay. Cool. What kind of stuff do you build in C? Yeah, let's do it. Let's remove E. Turns a pointer to the data stored in the element or null on failure. So what we want to do to be careful here about removing from the list while we're looping through the list. So the moment that we execute list remove here, this pointer is going to become garbage. Passing in the element happens to this. What's the current progress of the game? We are nearly complete with the game. I will show you a quick playthrough real quick in just a moment, but we are on day 49 of development, or this is the 49th stream, which have been spread out kind of, once or twice a week across about a year now. So this is not something that I'm doing full time by any stretch of the imagination. So all told, each stream runs from, anywhere from an hour to 3 hours, and there are 49 of them. So do the math, and we're probably looking at somewhere between, I would guess, probably like 100 to 100 hours of work. I don't know. I'll have to add it all up when it all is said and done. But right now we're adding a bit of animation in as kind of like some fun eye candy. But we're really gonna wrap it up. Maybe we'll wrap it up with stream number 50. I mean, 50 seems like a good number, and just move on to another project that may be similar, maybe different. I haven't really thought about the next project yet. I really gotta get on that because it's coming up quick. I haven't had a chance to work with C, C++ for 10 plus years, mostly C#. That's cool. Yeah, Handmade Hero is an excellent stream. That's kind of what acted as the inspiration for this stream. I had been I used to do C++ development, but I haven't done that many years, and I'd only done limited C, so I wanted to kind of dive deeper into C and learn about things like entity component systems, and I grew up in high school putting together simple games and stuff, and I just wanted to kind of get back into that. Do I make my own sprites? I could make my own sprites. However, this is a classic roguelike, so it is ASCII based. Why don't I just show you real quick, and then we'll dive back into this list code. So let me comment this out for the moment. But we won't have any, so theoretically do anything except forces to not compile. Left operating points destruct. Oh. Need to do, because we're dealing with a pointer. Let's try this. Alright. So here's our launch screen. So with this screen, I'm actually building my own graphics from an image. So if you toggle, this is the image that I used as the basis, and then I have an ASCIification routine that takes this image and looks at all the different cells and determines the best mapped ASCII character from a predefined set that I've defined, and you come up with this. And similarly for some of the other screens, like the inventory screen, you've got this scroll. Here's the image that it's being built from. One of the things that I may do, that I've thought about doing is, here's our ASCII version. There's no reason that I couldn't replace the ASCII characters that I'm putting on the screen with tiny sprites. And I got a sprite set from Onyx. I think it's Oryx Labs. They actually do a 16 by 16 sprite set for roguelikes, and each one of these cells is 16 by 16. So just by changing out the font map, I could theoretically replace this with sprites as well. Because this isn't a terminal-based roguelike, I'm not writing to the terminal, I'm actually rendering pixels to the screen. And if you look, you'll see the... let's quit this. Our ASCII characters, it's actually an image file that's just a map. So we're grabbing these 16 by 16 cells and blitting them to the screen. So it really doesn't matter. This could be, I'm using ASCII characters here. This could be 16 by 16 sprites. I've built it in such a way that, it just kind of operates on pixels. It doesn't really look and see what those pixels are. Alright, so we do not want to remove this item from the list. What happens to element when we do this? Grab the element data, to element to remove, we free the element, but then we remap. It looks like we do. No, so we're completely take it out of the list. It's not, this pointer is going to be garbage. So what we're going to do before we remove it, let's say, do this, and we'll actually remove, take the pointer, E to remove is what we'll actually send into list remove, but in the meantime, after we store pointer to E in our removal variable, we'll do E equals so we'll back it up, back up the pointer and go to the previous list item, so that when we remove the current list item, we won't, our list next will still work. That should work. Alright, so if the animation is done, we'll clean it up. Otherwise, we will, we're going to want to decrement our various counters and see if the work needs to be done. So we'll do, what is it? Don't even remember what we call these things. Ticks until keyframe, and then our keyframe interval. So we've got ticks until keyframe. We'll subtract 1 from this, and then we'll say if ticks until keyframe is less than or equal to 0, we're going to do some work. So we'll do anim keyframe animation is the function that we're going to call. We will call our keyframe animation. And we will also start our ticks until keyframe. Set it to our keyframe interval. So if our ticks is less than or equal to 0, then it's time to do some keyframe work, called keyframe animation. And then that will do something visual. And the next time through the loop, depending on whether it's set finished to true or left it as false, we may remove it from the list of animation work, or we'll just keep going. Okay, so now we need to actually build an animation. See what that looks like. All right, so we want to add the only the first kind of test animation that we want to build is something that makes our gems have some sort of visual sparkle or shine or something like that. So let's add that animation in when we're adding gems to our level. And I guess we'll add one for each gem. So level init, I believe, is what we're looking for. Adding
I'm on fire.
just thinking about this for a second. So I think we may actually want to add this as a component to our game objects, because if we're attaching it to a gem, when a gem is removed from the game, either because the player picked it up or because they are moving to another level, we're going to want that animation cleaned up. So if we make it part of the game object itself, it'll get cleaned up along with the other stuff. So we'll need to change, I don't know if we'll need to change structures we've built already. Yeah, I think we will. I think we're going to remove our global list of animations, and instead we'll probably loop through the game objects and test them to see if they have an animation component. I think that's how we're going to do it. So let's write the code that where we're actually using an animation, and then we can go back and figure out how we want to manage them. So this is where we're adding monsters, we sprinkle some items throughout each level, and then the gem placement. This is where we want to do our stuff. So we'll do animation. So we'll need to add an object ID to our animation structure. So we'll do gem D. Let's go back and do that. Oh. Come on, learn how to type. Object D. I think everything else in the structure is good. Keyframe interval and ticks until keyframe. Just gonna use these for reference, so like what it is that I'm doing here. So we'll do keyframe interval. How often do we want this to fire? So I think with the gem animation, what we're going to do is we're going to just kind of adjust the color value a little bit up so that it goes to white or near white, and then kind of goes back down to its original color, which is up here. It's like a purpley color. So our keyframe interval is going to be fairly low because I'm going to want to have multiple keyframes as we go from purple to like this whiter purple. So maybe we'll set our keyframe interval to something like 3 to begin with. I mean, again, we'll play with this. We'll see how it looks, and we can tweak this. Ticks until keyframe is going to be 3. Finished is going to be false. And then, so our keyframe animation we're going to set it to our unwritten function as of yet. So keyframe animation, we'll call it animate gem. We'll have to write that function. Object component, we'll do gem. We're going to add a comp animation. So we need to add a another enum value. Another animation here. Let's get rid of this. We don't need our animation list anymore. So we're going to be handling that. The animations will be contained in the components of the objects themselves. And when I say object, I don't mean object in the sense of an instantiated C++ object. I'm just, we've defined something called the game object that is basically a struct that can contain links to various components that make up that object. But it's not an object in the sense of object-oriented programming. Alright, so we need to where do we want to define our gem animation? Make sure where a good place for that would be. We'll need to adjust this list. We've added our gem, we'll add the animation to our gem. So we need a function named animate gem. And time put it, where will we put it? It's a good question. Just declare it here. And then we can put it like all the way at the bottom or something for now. Alright, so what do we want to do in this animation routine? We want to we basically want to adjust the color components of the gem's visibility to either be to cycle up to get to a light color that is near white, and then once that's complete, to cycle back down towards the original purple, and then kind of go back and forth between the white and the purple. So this is going to need to take the object. Do this. It needs to know what to do. Maybe it should take our game object? So we can't call it with no parameters because it has no idea what it's supposed to be operating on unless we give it that data context. So maybe we give it the object ID. Is that if there are multiple animations tied to a particular, well, maybe there won't be. Maybe that's a limitation of the system for now. So you can only have one animation per object. Which seems like a fair limitation for the sake of simplicity. Alright, so we're going to do some changes here. Let's go here. This is going to take an int, or an U32, sorry. I put it in the right place. Game object ID. And in our struct, this is going to take U2. So that when doing our level init, takes animate gem, set the values here. Okay, now let's go to our get animation component. We'll get the visual component. So that's what we'll be operating on. And then we'll adjust the visual component and update the animation component. And that's the scope of our work. First we need to get our game object. I think, if I remember correctly, we just kind of have our game objects here. Is it component get or get component? Get component is good. Game object get component. There it is. Game object go is visibility is what we call it. So because we want to cycle up and then back down, I think we need some kind of state, persistent state that tells us which direction we're going, whether we're going towards white or towards purple. But I want to make it generic enough that that it's not like specific to our one type of animation that we're doing here. Trying to think of a reasonable way to do that. Just have some generic value here. Just do something simple, like just do to you know, value 1, value 2. that seems it's not the prettiest, but I mean, I guess for now. Not my favorite. Just to find that value 1. Equals 0 to start. So if the value 1 is 0, then let's say we're moving towards white. Otherwise, it's white. Otherwise, we're towards purple. FG color, I believe, is what we'll grab the foreground color, and I want to see my stuff. Like a way to bookmark this. Our original color is right here, gem. And I think I have a way to get the RGB components. Color. There it is. I've got some macros. So if I give it set a color for RGB. Okay. These are what I need. And these are in the top of UI. Perfect. Red, green, blue, alpha. And they become what's this? So we're moving towards white. Let's towards white. Let's first check. Alright, we'll check and see. Get the different components. So we can just do this. It's red. No, I can do these outside. Let's bubble these. Look at the individual color components so that we can adjust them. Alright, so if we're moving towards white, we're going to add some value to it as we move towards, and these are each component is 8 bits, so its maximum value is 255. So once we hit 255 on any one of the components, we'll kind of call that as white as the color is going to get. So we'll do R plus equals, how much do we want to each frame adjust it by? Again, max val is 255, so maybe we'll just bump it by like 10 to start with, and again we can tweak these values. Type today. I know what this typing. Do if R is then 255, and if R is greater than or equal to 255, or it's greater to 255, or blue is, then we've hit kind of our maximum white. So start. So reverse course. So in this case, we won't adjust our color. We'll just change animation value 1 to be 1, which will get us moving towards purple. And perhaps I should just put some descriptive text here, what we're trying to achieve with this animation. Gem color will cycle up to maximum white, and then back to purple, original purple. Giving a shine effect or something, maybe. I don't know, that's the goal. It may end up looking nothing like that, but we'll give it we'll see what comes out. Alright, so we'll get the color components, we'll move towards white, if we've hit maximum white, reverse course, and then we're gonna return. We're not gonna do any more work this animation frame. We're not gonna adjust anything. So it'll render it the same like kind of whiteness that it was. It'll render two frames maximum white before it starts heading back down to purple, which is fine. So else, we're gonna adjust our color and we'll render it. Do viz fg color equals color GBA, and we'll do RG. Alright, so similarly, when we're moving towards purple, we're going to, hey, Dimitri, I have no idea how to pronounce your handle, I apologize. DMTR Lang, thank you for the follow. How do you say your handle? Welcome to the stream at any rate. Thank you for joining. Appreciate it. All right, otherwise we're going to move towards purple. So let's go back to instead of testing against maximum white, we're going to want to test against original purple. So what we're going to need to do here is define what those original purples are. So, or what those, yeah, what original purple is. So we'll do U32 kind of original red, red equals red from, oh, we've got the original color right here. So we've got RGBA. So we'll do OX. The red component is 75 in hex. O green is going to be X 3A. Blue is going to be AB. B. Type today. Do it. And O alpha is maximum. FF it's X. So in this case we want to test if less than or equal to. Now let's just do less than. Red. we've hit so reverse course. And in this case, we're going to go set that back to 1, or back to 0, so that we start heading back up towards white. Otherwise, we're going to set the update. And because both of these else statements are the same, we can just, instead of being repetitive, can move it outside this, move both of these. Because if we hit either maximum value, we're going to bail from this function immediately. And that seems like that might be everything we need. We're not going to update finished because we're setting the finished value on the animation to false, and we never want this animation to finish. It's always going to be cycling. So we'll leave that value alone. The only value we're going to be adjusting is this this kind of direction bit, if you will. And then the actual color of the gem itself. Could work. Guess we'll see. So the last piece is to actually call. We need to adjust our animation management, which was where? It's we put it. Animation update. Okay. So instead of looking at all animations in the list, since we don't have the list anymore, we're going to loop through all of the animation components. So we need to add, because we're defining this as a component now, we need to do a little bit more data work. Because we need we'll have a global animation component list. That's the list that we're going to be working. There's also some we add components. There's some game object component. Mr. Croatian, sure, you can see the game. I'm not sure. Is it gonna just run it? Command line here. So this is what it looks like. We've got our launch screen, and it's a classic ASCII roguelike. So all the rendering is done in ASCII. Got an inventory screen, so we'll get that. We'll equip our sword. And we can go get this goblin. We were lucky enough to spawn in the staircase room, but let's go see. There are gems scattered throughout each level. There are 5 on each level, and that's kind of how we keep score in this game. So if you're playing for a high score, you definitely want to explore the entire level until you locate all of the gems and grab those. Our shield here. And so, ground, where are all the creatures? Very lucky there's no, there's one, a kobold. We're able to kill that. Now we've got a couple of serpents. All the levels are procedurally generated. And all of the stuff in those levels is kind of placed randomly. Just gotta pick it up first. Grab the helmet. You can see we've got our stats here. Even the names of our characters procedurally generated from a list of name syllables. We've got our hit point bar, our attack and defense scores with some modifiers, and then what level of the dungeon we're on, and the number of gems that we have currently. You can see we found 4 of the gems on this level. There's 1 left. I think we'll just jump to the next level real quick before finding that last one. Just to show you. Descend further to level 2. As you descend further, the beasties get harder, you get a bit stronger, so on and so forth. And that's essentially the game. It's not the most ambitious roguelike. I wanted to keep the scope somewhat contained so that I could have a project that I could finish. But I think it has all of the elements, and those elements can be built on now that they're there. Look at all this. Is like the gem-tastic room. Look at that. But the project's kind of allowed me to explore building my own game engine, using an entity component system, and kind of figuring out how those work, figuring out the rendering and some cool algorithms like the field of view. There's an interesting... Oh, look, the sword and shield crumbled in my hands because as you move about, they degrade over time. And now we're going to meet a troll and probably just get our butt kicked. So let's show you the death screen. Boom. We managed to have our best run so far. We made the top of the Hero Hall of Fame. And so one of the other interesting algorithms is that all of these are actually based on actual images. So this is the actual image that it's based on, and then I run it through an ASCIification algorithm that turns it into the best fit subset of ASCII characters. And the ASCII characters that I use for that are really only the various sub-pixel forms. So there's like left half, right half, there's full pixel, there's, let me show you from the font map. So we're kind of using these pixels right here that are just, I didn't open it up to do a best fit on all the ASCII characters, because it seems like these really are the best ones for my purposes. So that's the game. Alright, we're going to copy pasta. We need to always be careful when doing copy pasta here. We're adding a new component. So this is kind of the component management. This is the function that will attach that component to a game object. So we'll do combination. It's just kind of tedious, repetitive, necessary stuff. Oh my goodness, delay. Okay, I think that might be the... Let's see what else, what other housekeeping we need to do. Level get open point. It's not necessary. Item get. Don't need that. I think that might be the all the housekeeping necessary for our new component. So let's go back to the animation update. Update routine, and instead of our animation list that we got rid of, this is going to be animation comps, which is all of the components, all of the animation components. Is this on the list? Let's look at some of our other update routines. Game update. Let's remove through all of the stuff. I guess it's while E. They are lists, so I can just loop through the list. Okay. Seems good. All right. So we'll loop through all of our animation components while we don't hit the end of the list. Get the component. If it's finished, we will. So if the animation is done, clean it up. Instead of just removing it from the list, we now want to remove it from our game object. Let's come back to the cleanup. Ticks until keyframe. This is still good. We're going to decrement our ticks. We're going to check and see if it's time for a keyframe. If it is, then we're going to call our keyframe animation. And remember, we added a parameter, which is the ID of our object. So in this case, we're going to do oh, come on. We're going to do anim. I think it's object ID. So we store the object ID along our component. So we'll pass that along. All right, so back to the cleanup. When an animation is done, we're gonna want to remove the component. Game object. Is it update component? How do we remove a component? I don't remember. Do we remove components anywhere else in the game? I don't know that we do. Oh yeah, certainly we do, because when somebody picks up an object, we remove their visibility component. So let's see what we're doing there. So we'll do item get, maybe? So it is get weight carried. No, item get. So when the player picks up the item, we remove it from the map. We just set its position to. So if it's null, we're clearing the component, and we're doing this list remove element with data. All right, so I think we're still going to need to be careful here. So we're still going to need this E to remove, where we'll do E, except instead of doing list remove, we're going to do game object update component. We're going to need to get a list of our, we're going to need to get our game object, which is fine, we'll do that. And then the component animation, and then we're going to set it to null. So we'll do game object equals that might be it. Well, let's see if it compiles. It does not, so let's fix that stuff first. How do I go? How do I jump? Control click. Yeah, it's not a pointer. So this is not a pointer. Because it's an array, it's not a list. Our game objects are an array. What else? What else is going on? Oh, we got issues. Oh, crap. Value is not a member of animation. Did I not do? Something's up with my copy pasta. Oh, whoops, yeah. so we need to make it specific to our... Got a bunch of stuff here. So we've got keyframe interval. Got ticks till keyframe. And then we've got keyframe animation. And finally, I think we have value 1. This is kind of all of the stuff in our animation. Oh, we need finished as well. Okay. Better. Keyframe interval undeclared identifier. Say what? Oops, I forgot my dots. That indicates it's part of the structure. Slaying these bugs right and left. Does this need to be this? And so, because yes. List, do we still have it somewhere? Ah, yes, we don't need that anymore. Couple to send the reference in to our game object. This is not... these should be pointers. Oh, it worked. Oh, it compiled and ran. I don't know that it worked. Let's see. So when we first see a gem, theoretically our animation is cycling now. We'll see what the effect is once we see a gem. Dispatch this bat. Come on, I want to see a gem. Oh, why would we be able to see the... Oh, look at that. Wow, that looks sweet. Sweet. Oh, hold on. Somebody's at the door. Okay. Give me 1 second. Alright, I'm back. Apologize for that. But good news, because look at that gem pulsate. Love it when a plan comes together. Look at that. So it's cycling between kind of our perfect white, or what do we call it, maximum white, and its original purplish color. Get it? Oh, when we get it, we crash a room. I think there was one bit of housekeeping that we forgot. When we destroy a game object, I bet we are not cleaning up that... I bet we're not cleaning up the animation. So it works great until you try and pick up a gem. Let's, which would be game object destroy, maybe? Yes, look at all this. Clean up, look, to do! Clean up other components used by this object. So we need to add one for animation. Grab the animation component if it exists on the game object when we're ready to destroy it, and we will just clean up that animation component as well. So then it'll be removed from the list that we're cycling through in our animation update, and we won't crash when we try and access a game object that's already been deallocated. Let's run it and see. Wow, this room is busy. I'm gonna die like right away. Boom. Okay. There's our gem. Will we be able to get to it? Ooh, it's bad. Alright, so now I'm gonna get it. And we did not crash, so now it's being cleaned up properly. Yay! Sweet. Oh, look, 2 gems. Because they're running essentially the same animation, they will pulse equally. Now, because we have tied the animations to our game loop, and we're not really regulating how often. I guess, are we getting a consistent frame rate for the... I don't know if we lock the frame rate or not, but it seems like the animation goes faster and slower sometimes, depending on how much else is going on. But maybe I'm just going crazy. Look at that. That's great. That's awesome. Alright. Cool. So we have successfully implemented an animation system, a very basic one, with a sample animation that pulsates our gems. And that is, that's exciting, at least for me. Let's see. let's see. Oh, and it's just about 1 o'clock, which is good because I think I'm gonna call it a day at this point. But we had a very successful session. I like when things work the first time through, or mostly work the first time through. We had that one cleanup issue, but so what did we do? We added an animation subsystem that gets run every single time through the loop, and it looks for work that needs to be done by any animations. Animations can be attached to individual game objects. In this instance, we attached them to a gem, and we built an animation routine that kind of cycles between near white and its original darker purple color, and just kind of loops infinitely. However, we did build in the ability to have have a one-time animation. So maybe it's just gonna explode or something at some point. If you wanted to add like an explosion animation, we could do that. And then when that animation in the animation work routine, we would need to just set the finished flag for that animation to true, and then the animation subsystem would clean that up when the animation is complete. Hazar, thanks for the follow. I appreciate it. So yeah, I mean, I think that's pretty much it for today. Oh, there's our gem. So next stream, there's not, as I was saying at the beginning of the stream, there's not a ton of work left to do. I've kind of completed my original scope. If we look over here, maybe we'll just do a bit more cleanup. We'll check for debug code that may be left, and then I'll play a little bit off stream maybe, and we'll see. There is still that phantom item bug where the item isn't visible on the screen, but you can it still displays a log message that's saying that there's an item there, and you can pick it up. It's really weird. So there are a couple little things like that that we can work on. But I mean, then it's drop the mic, walk away. We're done for this project, and we can either roll the work that we did this project into our next project if we want to do like another roguelike. Perhaps I think I'd want to do more of a graphical game next time. Do like either tile-based graphics or something like that, or we can just start fresh on a completely different project. So if you have an opinion one way or the other, what you might like to see for the next project, drop me a line on my Twitter, or via GitHub or any of that sort of thing. So I want to thank you for watching. I appreciate it. If you haven't already, hit that follow button. Let's see my wacky green screen here. Hit that follow button to be notified the next time I go live. And all of the archives are up on YouTube. The code, I will update the GitHub after I log off here. You can grab that and play along at home. Any questions or comments, hit me up on Twitter. I appreciate you watching, and I will see you next stream. Take it easy.